Welcome to Life Effects. I'm Dave and this is where I do stuff with effects. Before we create a new geometry node, we need to go back to our main island node where we had a null to output the mesh of the island body. Not only do we need the body, we also need a rough estimate where the edge of the whole island is. Luckily, we still have a group of points that can give us that information. When we fused both halves together, we had the group bottom edge. This group will help us to create the starting points for the vines. So to isolate the group, I create a blast node that deletes everything else. Select the group and activate delete non-selected. Those are the points that we were looking for. And finally create a null so that's easy to locate this node in the other geometry network. Bring the visibility flag back where it belongs and jump one layer up. Now we can create the vine geometry node. Jump inside and again we start by bringing in the island body. Create the object merge node and select the null with the body mesh. We will shortly use the color attribute again. So we'll set the attribute to 0. This would be the same as creating a color node with the color black. Just type in @cd equals 0. Then create another object merge and bring in the edge points. My plan is to mark those points on the island that are in close proximity to these edge points. But depending on your island design and level of detail, you might have quite a lot of points that are not needed to be tested. So to prevent unnecessary testing, I blast those points away that are too high or too low on the y-axis. So bring in a blast node and type in @p point y bigger than 0.8 and change the group type to point. Then we need another blast node and this time we want to get rid of everything that is lower than -1. So again, @p point y lesser than -1. This doesn't need to be that precise, it is only supposed to concentrate the next operation on the relevant points. Instead of the whole mesh, we only need to check what we left here. I recently did a video on using point clouds to find points. Here's another application for clouds. Create a point wrangle and then connect the edge points into the second input. Now I can open the point cloud with these points, but on the basis of my island points. Use PCOpen on the second input, use the point attribute and deliver the point vector of the current point that came through the first input. We search with a radius of 0.3 and we only need to find one point. Then I check with an if statement if the point cloud has found anything. If that's the case, I set the color of that point to 1. This will paint that area white. You can play with the radius of the point cloud for different results. Or if you want to make it a bit more visible, instead of setting the whole color attribute to 1, only set the red channel to 1. This is the area where we want to distribute our starting points. And the point of this is that we can now use the scatter node. With the default setting, this distributes the points everywhere where the geometry offers any points. But there's an attribute for the density. Activate the attribute and change it to color. And now we have our vine points. Maybe we need a bit more. Let's force the amount to 1500. We need to make sure that the normals of the island come with them. If we activate the display normal switch and go back to the wrangle, these are the normals we also need for the scattered points. The data is here, but not active. So just write @n equals @n, and that will write the normals into the spreadsheet. And while we're here on the spreadsheet, it might be a good time to do a bit of cleaning up. As you can see, we're still carrying around attributes like rate, which we used to paint the initial body. Also, there are a few groups that we don't need anymore, but the more attributes we keep dragging along, the more performance hungry our project gets. A good practice would be, as soon as you don't need an attribute anymore, just delete it. If you find a use later on, you can still come back and reverse it. The point attribute weight can go alongside with all of these groups. And of course I have to do the same for my output of the edge. Here it is a bit easier. I just can use a wildcard since I don't need any attributes or any groups. But this is all we need to create the VEX vines. For that we create a for each subnetwork. It will use each number and continue for each point that is there. For good measure we change the stamp from for value to vine ID. Since we know that there are 1500 points, we could just type in 1499. But to stay procedural, type endpoints, op input path, point, 0 and -1. This will return the amount of points on the first input. Make sure this option here stands on merge results, otherwise this will duplicate the points like crazy. Before we dive into this, I know VEX is quite a lot to digest if you're new to this, but just follow along for now. I'm working on the Pluralsight VEX course at the time and it will cover all the important basics and more to get you going with VEX. As soon as it's published, you will hear it here on the channel, so consider subscribing. Until then, just let me know if any questions come up and I will try to solve any problems you stumble upon. As a first step, we want to blast every point that is not the current one using the stamp expression. In this situation you have to frame the expression with apostrophes, then write stamp point, comma, vine ID, comma 0. This will give us the current ID from 0 to 1499. And don't forget to switch on delete non-selected. So this point is a bad example for what I'm trying to accomplish. To give you a better demonstration, I create an alternate version of this blast node and just use the ID directly. And number 3 is a good one. Now what I try to accomplish is to create a vine that starts to shoot out in the direction of the normal and then bend downwards. To do this I use 3 points. The start point, a point somewhere up here, and then one here to mark the bottom. But I also want each vine to have a random length. So let's get to it. The first one is fairly simple. Just create a new point, use the original position and add its normal value. This will work for most points, but there will be a few where the slope of the start point is very strong, just like this one. It will not look very good. We want the final curve to be smoother. And one way to solve this issue would be to do it like this. Create another wrangle and set it to detail. First I grab the position vectors of both my points, like so. And of course the position attribute is a capital P. And if the position of the new point on the y-axis is bigger than the old one times 2, then I want to divide the new y position by 2. Set the position of the new point to the lowered value and the point falls down quite a bit. Again, just play with the numbers to get a result that suits you. Next we need to find a way to create the third point. For convenience I blast point number 0, which was the start. This leaves me with the new created one. With that I can leave the wrangle on points and use the predefined attributes. Set the normals to 0, -1, 0, so that it points directly downwards. And again I want to create a new point. This time I also use the position plus the normal, but this will only bring us 1 unit down. Let me quickly combine all 3 points so that you can see what this will look like. For that I go back to my initial creation of the second point. This time I blast point number 1. And now I can merge all 3 points together. At the moment my for each subnetwork only works with ID number 3, so for a quick test I have to switch the initial blast nodes. So far so good. The for each subnetwork does what it should. For each vine point it creates 2 new points. Problem is, each time it's only 1 unit. And we need to change that. Not only do we want to increase the distance, we also want a random factor for the length. This can be a bit tricky in VEX. Let's just assume we want to create an integer seed for the random distance. Then we create a new float variable and use the rand function with that seed. That gives us a value between 0 and 1. And we want to fit that into a new range between 2 and 5. And that allows us to multiply the amount of normal values we add for our third point. That seems to work. If we change the seed, the distance between the points changes. But when we go one layer up and look what happens with all the other points, this still looks like a very uniform length. If I now pin the viewport and go back to our node where I can change the seed, you can see that all of the new points changed to a uniform length. The problem lies with our random seed. Each iteration of the for each loop will use the same seed. The rand function will always deliver the same value if you use the same value as a seed. One simple way to solve this would be to use the stamp as a seed. Each iteration of the for each loop will use another vine ID. This would be sufficient as a randomized seed. But this has one drawback. I'm not entirely sure why this is the case, and if you know that, you're welcome to enlighten us in the comments. This way of solving it works, but it takes a lot of processing. When this is finished, you can see that we indeed have randomized distances. There's another way of doing this, with much better performance. And the only thing you have to change is to use another function for the random value. First, we get rid of the seed that we got from the stamp. Then instead of the rand function, we use the function called random. Instead of a value to generate a seed, this function can use a position vector. And since each of our vine starting points has its origin at a completely different vector, it's ideal for our situation. And just for the case that you did not notice the difference, we just skipped all of the processing we needed to do before. The character of each randomization differs from the approach you take. But let's get back on track. We now have the 3 points that we needed. As a next step, we need to draw a line that combines these points. Create another wrangle and set it to detail. Start by creating a new primitive. We need a polyline and now add vertices for each point. The handle is always 0 for the first input, the target is the new prim, and the point numbers are 0, 1 and 2. Then I resample the line to get even more points on it. Lower the length to about 0.03. This should make the bending smooth enough. Like in the last episode, we make use of the built-in curveView attribute. This creates a value from 0 to 1 dependent on the position on the line. The bending itself is now a piece of cake. If you take a closer look at the normals, they are blending between our 3 initial points. They start with the normal from the island surface, then change into the straight downward normal. And our last point had no normals. Put that all together and you can make the following one-liner in a wrangle. Add p plus equals add n, multiply by curveView. The fact that curve U has a very low value on the first points prevents these points to make a leap that would be too strong. And while the value of curve U rises, the length of the normal is decreasing. So now I can finally switch out my testing blast at the beginning with the real stamp blast, and now I can jump one layer up and admire our vines. We will leave it here for this episode, and the next time we follow up on this by creating leaves that we attach onto the vines. In the next VEX quickie we will convert the noise swap that we used here and write one single attribute wrangle. So stay tuned for that, and I see you next time.